Our topic for today is about how to calculate the charge of the nucleus of an atom. At the end of this video, you will be able to recognize the elementary charge of electrons and protons, calculate the total charge of the nucleus of an atom. The charge of a single electron or proton is known as elementary charge. It is denoted by small letter e, and it's equal to 1.6 times 10 to the power minus 19 coulombs. We have two types of elementary charges. We have the elementary positive charge of one proton. It is equal to the same value but with the positive sign. And we have the elementary negative charge of one electron. Also it has the same value but with a negative sign. Capital letter C is the symbol for coulombs, which is the unit of electrical charges. Suppose we have the following unknown atom. Inside the nucleus we have the protons and we have the neutrons. For the neutrons, since they are neutral, we can say that the total charge of the neutrons is equal to 0. Now what about the total charge of protons? To calculate the total charge of protons, they will be equal to the number of protons inside the nucleus times the elementary charge of one proton. For example, if this nucleus contains 15 protons and you have the elementary charge of one proton, calculate the total charge of protons. So you have to write that the total charge of protons is equal to the number of protons, which is 15, times the elementary charge value, which is given. So as a result, we can say now that the total charge of protons inside the nucleus is equal to plus 24 times 10 to the power minus 19 coulomb, and always have a positive value since they are positively charged. So how to calculate the charge of the nucleus, or what do we call the nuclear charge? The total charge of the nucleus is equal to the total charge of its nucleons, which are the protons and the neutrons. So we can write here that the total charge of the nucleus is equal to the total charge of protons plus the total charge of neutrons. But the total charge of neutrons is equal to 0 since they are neutral. So we can say that the total charge of the nucleus is equal to the total charge of the protons only. So in return, it's equal to the number of protons times the elementary charge of one proton. Instead of number of protons, we can write capital letter Z, which is the atomic number. And instead the elementary charge of one proton, we can write small letter e. So here in this formula, capital letter Q, it represents the total charge of the nucleus in columns. Capital letter Z, it's the atomic number. Small letter e, it's the elementary charge of one proton. This formula can be written in this way to simplify it much more. So we can say that the total charge of the nucleus is equal to the atomic number times the elementary charge of one proton, and the answer have a positive value since protons are positively charged. Now let's solve this application in order to understand more how to calculate the nuclear charge. In this application, you have to calculate the nuclear charge for sulfur atom. Given the atomic number, it's equal to 16, and you have the elementary charge, small letter e. So directly you can write the formula. You can say that the total charge of the nucleus is equal to the atomic number times the elementary charge, having a positive value So just substitute the given. You have the atomic number here, it's equal to 16, and you have the elementary charge. So we find here that the total charge of the sulfur atom nucleus, it's equal to plus 25.6 times 10 to the power minus 19 coulomb. Thank you for watching.